For this, as a result of what we get from all the properties we talked about, all the things we can do with factors, zeros, roots, we say that if we have a polynomial function f of x of degree n where an is not equal to 0, because if an equals 0, it's not degree n anymore. We're just being dumb, and we don't be dumb, but we do have to be specific. Math is a very specific language. But if we have that leading coefficient an is non-zero, and we've got some general degree n polynomial, then we can rewrite that as a product of its roots. We can write it as an times x minus c1 all the way down to x minus cn, where you might think to yourself, how does this help us find the roots? And it doesn't. This kind of assumes we already have them. But what we can do here is, if you want to get a general flavored polynomial, something like this, we can do so using a condition for the function and knowledge of the roots, like we'll see with an example. So for this example, we want to find a third degree polynomial f of x where f of 2 equals 40 that has -2 and I as its roots. What we can do here is start by saying that based on the linear factorization theorem, f of x is going to be equal to some value an times x plus 2 because it has -2 as a root, x minus I because it has I as a root, and by our properties, it will also get x plus I as a root. And if we want, we can multiply this together now, or we can wait until after. Personally, I don't mind waiting until after because it's a little bit easier for me to just plug numbers in like this. To find an, what we can do is use that condition that f of 2 is equal to 40, where we would have that is also equal to an times 2 plus 2 times 2 minus I and 2 plus I, which ends up being an times 4, and because these are conjugates, you would end up with 2 squared plus I squared, which is 5. So you would have 40 equals 20 an, or 2 equals an. And then if we want to get our function f of x, we can get that just by taking all of our pieces now and multiplying them out, where I'm a little bit low on space here. I'm going to skip that little bit of writing out the multiplication. We would have 2 times these guys. That condenses down to x squared plus 1, as we saw before. Multiply that times x plus 2. You don't have to do quite as much with foiling. Multiply in the 2, and what you should end up with is 2x cubed plus 4x squared plus 2x plus 4. So if we want to get something like this, given some conditions, it's just a matter of multiplying and a little bit of care with our division as well. Now the last thing we're going to see here is one more semi-characterization, one more potential description for how these things interact. It's a bit picky. I'm not a huge fan of it because it's just got so many different moving parts, but we're still going to look at what's called Descartes' rule of sign.